Welcome to our Innovation Fireside Chat. With me today is Sujeet Chand, SVP and Chief Technology Officer at Rockwell Automation. Thank you for joining us today.
I'm delighted to be here.
And also with us is Nelson Petracek, Chief Technology Officer at TIBCO Software. Thank you, Nelson.
Oh, good. Looking forward to the conversation.
So, we thought we'd talk about, especially with your area of expertise and your background, Sujeet, around areas of industrial IoT. And also, I think we thought maybe we'd inject some flavors of blockchain into that as well. There's some upcoming areas where these things start to converge. And in industrial IoT, I thought what might be good is if we started with you guys both talking about some general trends and directions that you see. I think also maybe you mix into that some use cases, maybe good, bad, both sides of that, that we could share with folks. And probably I'm giving you a lot at one time, but I figure we're going to kind of just go through maybe 3 topics and it'll probably be enough. But also, there's areas I think for the general audience talking about terms that we hear, it might be good to break some of those down, and just some of your general experience. So we'll start with you, Sujeet.
So industrial IoT is a term that has become popular in the last, I would say, 2 to 3 years. But if you look at the manufacturing environment, the industrial environment, we've been implementing IoT at a low level for quite some time. What that means is a lot of the assets that are in the industrial space in manufacturing are already smart assets. Mm-hmm. They've got a processor on the asset. The processor is processing information from the asset. It's connected to a network. It's relaying the information on the network. The assets do have sensing in them. There's always need for more sensing. But what's been missing is the application of AI and machine learning to run data analytics, to extract more value from the data. So what's changed in the last, I would say, 4 to 5 years is the convergence between what we call the operational technology environment, OT, which is essentially your manufacturing environment, convergence between that and the IT systems. So as IT and OT are coming together, the opportunity for taking data from the rest of your enterprise and mashing it up and analyzing that data along with the data from your manufacturing environment is really exciting, because now you can drive business benefits that you were never able to before. So that's why there's so much excitement around industrial IoT in the manufacturing space.
Right. Yeah, and that makes sense, because we see the same thing where people historically have had systems in place where, manufacturing's been going on for quite some time.
Long time.
They've got control systems, they've got these lower level devices. But what people are really looking at doing now is saying, well, how can I better leverage that information that's coming off of those devices and applying things like you said, AI and ML and other types of techniques. We also see a trend towards people saying, well, I can't necessarily bring all the data back from these devices all the way back to the data center, to the cloud. I need to be able to do some processing closer to the edge or fog computing, things like that, or some of the newer terms that people will talk about. And so there's almost this idea of some of that analytical capability that I do in my data center, in my cloud, push that down to the edge and do it locally.
Absolutely, because we talk about scalable computing. If you look at controllers and assets that are in the manufacturing environment, the amount of compute power is growing dramatically. So for example, a controller that Rockwell makes today typically has a quad-core processor in it.
Okay.
There's a lot of processing power there.
Sure.
Just close to that processing power, you have Windows IoT machines. And those Windows machines also have significant processing power. They're plant floor servers. So if you ignore all that scalable processing that's available at the edge and only focus on the cloud, that's the wrong solution.
Sure.
That is definitely the wrong solution, because that's going to give you the big data overload problem.
Right. And in fact, you actually, it's interesting. You hear less about the term big data today than I think you maybe did 3 years ago. Again, because of this focus, I think, of having to push processing out to the edge to get away from that problem.
Correct.
And I always talk about things like reducing decision latency. So the time between when you identify a problem and maybe respond to it, you want to shrink that down.
Yeah.
And so you can only do that in many ways by pushing out the logic to the edge and let the edge make that decision. In many cases, not always, but in many cases.
Just to be provocative, I like to say that in 5 years, we won't be talking about big data.
Sure, yeah.
So a lot of people don't agree with that because they are assuming that you need to collect as much data as possible, dump it into the cloud, and then run analytics on it to figure something out. We don't know what it is, but we'll figure it out. So with that thinking, companies that are in oil and gas space have collected petabytes of data. It's not unusual for them to have 25 to 35 petabytes of data. They're now wondering, what the heck am I going to do with all this data? Because it's not producing the value that they're expecting. And it's not free to store 20 petabytes of data. You have to write big checks to store all that data. Right?
The database vendors would love you for that.
Yeah, of course. So a lot of companies are beginning to think about how do I, to your point, pre-process the data and only move the data that's relevant to processing in the cloud. In many ways, I think we have it backwards. We're thinking collect all the data, dump all the data, extract value. Really, it should be the other way around. You got to be thinking about what is the business value that I want to focus on. That's going to drive the type of analytics I want to run. And that's going to determine what type of data do I need. So we really have to kind of think of this starting with the business value to analytics to the type of data that feeds the analytics. Companies are beginning to realize this now. So this is a shift that's occurring in the market. But there are people who would say you should collect every data.
Just everything all the time, right?
All the time.
Right.
So what I point out to them is a lot of manufacturing systems are non-stochastic systems. What that means is these are man-made machines. These are machines designed by people. They follow the law of physics. We know the behavior of a lot of these machines. Stochastic systems like predicting what causes cancer or predicting the weather, yes, those type of systems need big data because we don't know the correlations. But in manufacturing systems, we know a lot of the correlations. So when you know the correlations, you can filter the data where it's generated, and then based on the business outcomes, select the right data. That insight, I think, is important in the manufacturing space.
Right. Yeah, that makes sense. And actually, we see it in other use cases as well. So, Formula One, TIBCO is a big sponsor of Formula One and one of the Formula One teams. And in a race weekend, they can collect terabytes of data off of a car. They'll have 350 sensors or so running on the car during practice. They'll create that digital twin, which is one of the buzzwords that you alluded to earlier. Anyway, so they get a better understanding of what that car is and the representation of that car, again, from the sensors, anything from engine to gearbox to tire temperatures. But they need to collect that data so they can make better real-time decisions on race day, so that they are competitive, when hundredths of a second matter. But utilities is another example, distributed energy resources, solar farms. These are all areas where taking that processing, pushing it out to the edge and making more decisions at the edge are going to be very, very relevant.
Yes, and the way we look at analytics, the way we look at edge processing, we think of analytics and processing in two categories. We think of real-time analytics, where the analytics produce real-time actions. Okay, so what that means is you discover that a pump is going into cavitation. You change the set point in the controller to slow down the pump in real time. Or in addition to that, you may create an alarm for the operator to make some changes to the system. Non-real-time analytics typically run in the cloud, cannot change set points in the controller.
Kind of a little late by the time they probably
by the time, exactly. Exactly. Yeah. So to your point about edge processing, this is really important because doing everything in the cloud is going to only happen when the airbags in my car deploy from the cloud.
Right.
I don't think it's going to happen in my lifetime.
That's true. I use the example of a stop sign. You see the stop sign, you send it to the cloud, and you tell it, what should I do with the stop sign? By then, it's way too late. Yeah, that's
when
very
the flashing lights go off behind.
Yeah,
you.
exactly.
Right.
Yeah.
So I guess a little bit more on the digital twin, and then some of the comments also about your talk about at the edge, and that interoperability, that analytics, those things that are happening at the edge, obviously, certainly infer more AI and more machine learning, and maybe we could chat a little bit more about that. I mean, that's one of the obviously big hot future trends right now is talking about that, especially at the edge. And by the way, I'm a believer in you. I'm completely with you in terms of we will not be talking about big data in 5 years. In fact, I don't think it'll take that long. So I'm in your camp. Anyway, let's talk a little bit about that, that interoperability. And I think some other things in newer networking areas, the challenges of networking those devices together we're facing. Mesh networking and some of those areas are becoming really hot topics as well. I think we start to blend that together now and talk about, okay, we can't bring the data back, so how do we do things better at the edge and using some of those technologies?
So I would say start again with the definition of digital twins, because today digital twins is like three blind men feeling an elephant. No one has a clear definition of what a digital twin is.
Right.
Because it's a much abused term. But basically, when you think about a digital twin is a digital representation that's connected to the sensory inputs from a physical process to produce some business value. Right. Not for the sake of just having a digital twin. You got to think again about business value. The digital twin itself changes based on the question you want to answer. If the question you want to answer is my machine running according to my expectations? Is the quality throughput according to my expectations? Right. If that's the question you want to answer, the digital twin has to have the models to give you that information. If your question is something else, if you want to know how this machine is performing relative to similar machines in 50 other locations, the digital twins that you would need are different.
True. Yes. Yeah.
So this concept of one digital twin is incorrect. The digital twins are really digital representations of an asset or a process that is driven by the business outcome you want or the question you want to ask it.
So you'd have a mapping back to, from the source or sources in this particular context to the twin, which is trying to achieve or answer some sort of business
Exactly
question.
Right.
Yeah, okay.
Exactly right.
Okay.
Yeah. So this notion of having one digital twin, which is the most complex model of your machine, and may take you 50 years to develop, is the wrong notion. Okay. That's not where we're going.
Yeah, that makes sense. That makes sense, yes. I know, you alluded to some of the futures out there and AI and ML and those kinds of things. I think you'll start to see a broader, it's not just about an algorithm. And this actually relates back to this concept around digital twin, that it'll be actually a series of capabilities. So
Correct.
You're going to see more things around probably like cognitive sensing and
Exactly right.
video and audio recognition
Yes.
and some of these other aspects. It won't just be necessarily a pure mathematical model like most people will think about the application of AI, ML.
Exactly.
Yes. We'll see some of that, I think, as well.
So I guess, as we maybe get close to wrapping up, one of the things I would like to jump to before we close out, and I think we only have a couple of minutes, so kind of keep these ones as brief as we can, but futures. We talk a little about futures. Some of the areas, again, around autonomous devices, security. Security is a big issue, when you think about an environment of an IoT outside of the control of your plant or something like that. What about that? I know, Nelson, one of the big things I hear you talk about all the time is consideration of blockchain.
Oh, you wanted a short answer. Now you just messed that up.
I use the keyword blockchain, which means long answer. But talk about maybe some of those areas, I think, before we wrap up would be awesome.
I'll just touch on one just to carry that. I'll keep it short, I promise. I think micropayments are going to be interesting. Having devices pay one another for capability. And that kind of alludes to blockchain and all that, but we won't get into that today. That'll be a topic for another time. But I think having devices act autonomously and kind of coordinate with one another for certain capability, I think that could be interesting down the road.
Yeah, I agree with that. So blockchain is relatively new to the manufacturing industry, and a lot of manufacturing companies are looking at blockchain for secure transactions, all the way from supply chain to manufacturing to distribution to the end customer. How do you create a link of secure transactions? So they're looking to blockchain potentially to help solve that problem. So there's just a plethora of technologies that are emerging that is going to shape the future. The concept of a lights out manufacturing is yesterday's concept. the concept for manufacturing for the future today is it's a living part of your enterprise. It's connected to the rest of your enterprise. It's driven by your customer demand, your supply chain, and at the end of the day, what drives revenue for your company.
Exciting stuff.
Yeah.
Exciting stuff.
We won't be bored for a long time.
For a
Yeah,
long
I would
time.
expect, yes.
We've all been in this business for a long time, and I tell you, it's very exciting this day and age right now.
And we call it the inflection point. We are
Yeah.
at the inflection point
Yeah.
for dramatically changing what manufacturing is going to look like in the future.
Interesting.
Well, thank you both so much for joining me today. I
Pleasure.
appreciate it. Nelson and Sujeet, it's been wonderful chatting with you. Great conversation, and certainly a lot to look forward to with the future and some of the things we talked about today.
Excellent. Yeah, thank you.